is about quadratics. I'm not going to go through every single question with you. This is a revision sheet for you. You need to complete the questions by yourself. I will upload solutions by the end of next week, okay, for the whole booklet. So you need to complete the whole booklet by the end of next Friday, okay, so for the whole thing. And, okay, for the first one is factorize, okay, for the first one is factorize. I think you can factorize, okay. One thing I want to mention here is, let's factorize this first. So, for the way I used to factorize this, the coefficient of that is 1. So I can just make 1 and 1 here. For the negative 22, I will have negative 11 and 2 or negative 2 and 11. So 11 and 2, one of that needs to be negative. So I need a positive 9. So I will give a positive 11, put a negative 2 here. So let's cross multiply them and plus them together. That's a 11 plus a negative 2. And we'll give you 9, which satisfies because the middle number is 9. Okay, I'm not sure which method you use, but if you can factorize easily by your method, it's okay. For the ones who cannot factorize, so I will introduce this method. So for the first column, I will factorize the coefficient for the first term, so which is 1. In this case, I will have 1 and 1. And for the negative 22, I will separate to this one. There will be several combinations. For example, 1 and 22. Negative 1, 22. Negative 22 and 1. 11 and negative 2 and negative 11 or 2. But you want to cross multiply them and add them up to make the number in the middle. Okay, you want to make the number in the middle. So negative 2 and 11 will make the number in the middle, which is alright. And I can write things horizontally. The first number, okay, you write this row and this row. The first number means the number of x you have. You have 1x, so it is x plus 11. And x minus 2. Okay, that's how you factorize that. Okay, y equals to x plus 11 and x minus 2. Okay, by the next one, the coefficient of the x squared term is negative 15 now. So negative 15 can be 3 and 5, negative 3 or 5, negative 5 or 3, or 1 negative 15 or 15 negative 1. But like you will start with two numbers close to each other, which is 3 and 5. You won't start with 1 and 15. So I will start with 3 and 5, but I'm not sure where to put the negative sign. So I put a negative here to decide. And I need a 6. Okay, I need a 6. I need a 6, which I will start with 2 and 3. I'm not going to try 1, 6. I'll try 2 and 3. So let's put 2 here and 3 here. Okay, let's cross multiply and add them. That's a 10. That's a 9. But don't forget, you will have a minus sign for the first one. Okay, you need a negative 1. Can you see the middle number is a negative 1? That's a negative x. You need a negative 1. Therefore, 10 and 9 can make a 1. So I need a negative 10, right? I need a negative 10. So I will have a negative 10 here to make a negative 1. Therefore, the negative sign will go to the negative 5. Because 10 comes from 5 and 2. And that's a negative 10 plus 9 is a negative 1. And which is satisfy this case. So I will have 3x plus 2 and minus 5x plus 3. Okay. I marked the year 12 paper yesterday, like they have a pre-test yesterday. And I marked the paper. What I find is they still make mistakes in one point. I have emphasized that to my year 10 students last year, but I want to emphasize that again today. So if you have equation y equals to 2x squared minus 12x plus 2. Okay. Make sure you know that it's not equivalent to x squared minus 6x plus 1. Okay? Make sure you do not write that. I still have answers from year 12. They said, oh, y equals to 2x squared minus 12x plus 2 will be equivalent to y equals to x squared minus 6x plus 1. Okay, they automatically divide the 2 when they see every single term contain a 2. But you cannot divide this down. That's not an equation. That's an expression. How you can just make that 2 times less than before? If you divide the 2, you decrease it. Okay, you decrease this twice. But if you have 2x squared minus 12x plus 2 equals to 0, in this case, you can say that x squared minus 6x plus 1 equals to 0. That's no problem. Okay, because you divide the 2 on both sides. Okay, you divide the 2 on both sides. For this one, you just divide the 2 on the right-hand side. You have nothing to do with the y value. So you cannot do that. Okay, I know you may think that's easy point, but when you do the paper, we will see, oh, 2, 12, 2, oh, nice, I can divide by 2, and you directly do that. Okay, make sure when you try to divide something, think about, should I divide it here, or I should divide it on both sides? Okay, any case, you need to divide on both sides. If you remain this y and divide only on right-hand side, that won't be correct. Okay, so that's something I want to say here. And for 3C, it's just a solve question. I want you to solve for it. Okay, okay, next one. Okay, graphing the quadratics. I want you to graph it by this form. You can either complete the square. Okay, you can complete square, or you can factorize. Okay, if you can factorize, factorize it. If you can complete the square, complete the square. You need to have either intercept form or turning point form to sketch a quadratic. Okay, you cannot sketch a quadratic by looking at the general form. That's the general form, you cannot sketch it, either from the turning point form or the intercept form. Okay, if you factorize that, that will be the intercept form. If you complete the square, that will be the quadratic form. Okay, I'll pass that. Okay, for 3E, Okay, for 3E, I will do this with you. Okay, so solve the following equations for x by first completing the square. Okay, by first completing the square. Let's copy this question down again. Okay, complete the square. So how do we complete the square? I will write things in order x squared minus 5x plus 2 in this order. Okay, I'll check first. Do I have coefficient 1 in front of the x squared? We have 1. Yes, that will be the easy case. I can factorize that easily. So I will keep the first 2 terms. Okay, I will add half of the b value square, and I will subtract half of the b value square, and remain the constant there. Okay, do not change the constant. So what I have to do is add half of the b square and minus half of the b square. Okay, for the first 3 terms and next 2 terms, I will combine them together. For the first 3, what I will take? I will take first terms x, second terms the sign, and the third one's seen in the bracket. I'll take those 3 values. So I will have x minus 5 over 2 whole thing square. Okay, x minus 5 over 2 whole thing square. Okay, take the x, take the negative, take the 5 over 2, put them together, square them. And minus 25 over 4 plus 2. Plus 2 is 8 over 4. Okay, equals to 0. And x minus 5 over 2 squared will equals to 17 over 4. If you move the 2 constant to that side, it's negative 17 over 4, so move to right hand side will be 17 over 4. Okay, now I'm trying to solve for it. How we can solve this? Do not tell me open the bracket and then solve that by using quadratic formula. If you're already in the completing square form, turning point form, that will be really easy to solve. Okay, this will be really easy to solve in this form. Okay, a simple question: x squared equals to 4. What x equals to? Okay, plus minus 2. Plus minus 2. Okay, so now this thing square equals to that. What's that equals to? So x minus 5 over 2 will equals to plus minus of square root of 17 over 4. Okay, if you try to get rid of the square, okay, you just square root both sides. But when you square root that, you need to have the plus minus sign. Okay, you need to have the plus minus sign, because that thing square, you can treat that thing as a whole thing, like a square equals to that. So a equals to plus minus of square root of 17 over 4. So x will equals to 5 over 2 plus minus square root 17 over 2. Okay, you have two values. All right, I'm going to go through one last example today. Which is solving quadratic inequalities. That's a new thing. Okay, that's a new thing. I want to do this today, and you can revise on that on weekend. Shh. Okay, one last example. So I have x squared minus 5x greater or equals to negative 2. So what you need to do at the beginning of solving quadratic inequalities is move everything to one side. Okay, move everything to one side. So I will move x squared minus 5x plus 2 greater or equals to 0. Well, I will leave this one to you, do it by yourself. I will do the right-hand side one. Right-hand side one will be a good one to explain. Okay, I have everything on one side now. Okay, so I will take negative 7 as a common factor. Negative 7 x squared minus 7x plus 6 smaller than 0. Okay, can I divide by negative 7 here? Yep, I can divide by negative 7. So x squared minus that. Okay, what's the sign here? What's the sign? Greater, right? Greater. I need to flip the sign because I divide a negative number. Okay. To write something to tell yourself, except linear inequality. Except linear inequality. Every inequality will need graph to solve. We will need graph to use to solve for it. Okay? Except linear inequality. Linear inequality we can directly solve algebraically. But anything else other than linear inequality, you need a graph to help you to solve for that. Okay, that's a really important skill. You need use this in a lot of topics. Okay, a lot of topics. Okay, so basically to solve inequalities for quadratic, cubic, quartic, like higher polynomials, you just need to move everything to one side and put 0 on the other side. And what you need to do is draw this graph. Okay, draw this graph. You want to draw x squared minus 7x plus 6. I want you to draw this. So to draw this, I will factorize that first. X minus 1, x minus 6. Okay, I hope you can see this. X minus 1 times x minus 6 will give you that. That will be greater than 0. Okay, let's sketch this. Let's sketch this. I will have intercept at x equals to 1 and x equals to 6. And this is a happy graph because the positive x squared value, so it's a smile face. Let's do that's a smile face. Okay, that graph roughly look like this. I don't really need to find the turning point. Let's say that's a 6, that's a 1. Okay. You want to find the x value to make this graph to be positive, okay? You want this graph to be greater than 0. You want the y value to be greater than 0. So which part of the graph is above x-axis? Let's draw this. This part of the graph and this part of the graph is above x-axis, right? Those two parts, those red part is above x-axis. So what's the corresponding x value to give those two parts of the graph? Which is this part of the x and this x will give you those two graphs. Okay, I want y greater than 0. Okay, I want this greater than 0. I want this value to be greater than 0, which is this part of the graph and this part of the graph. So which that x values can give you those graphs will be this part of the x and this part of the x. See, this x will be corresponding to those graphs. You see that? Okay, go that way. So not this part. So your answer will be this part of the value and that part of the value. So which is x smaller than 1 and x bigger than 6. Okay, x smaller than 1 and x bigger than 6. Okay, that's overall what you have to this question. So if you can simplify that, if you can find any common factors, divide the common factors on both sides to simplify the equation a little bit. And you factorize the equation. Because it's not a linear inequality, we need a graph to help us to solve for the inequality. And we draw this quadratic. Okay, we draw this quadratic. It's a happy face. You have intercept 1 and 6. The graph will roughly look like this. I want the value greater than 0, which will be this part of the graph and this part of the graph. What x values can give you those two parts of the graph? You will do this part and this part. We'll have those two graphs. So that x smaller than 1 or x greater than 6 will be the final answer. Okay? Any questions according to this?